Okay, so this is the next problem of interest. Okay, so here we go. I have rewritten it. Okay, so let's see. I'd like to find df dx, or shorthand f sub x. Okay, so I'm going to go up here, and in my box I'm going to write down how this is behaving. Okay, this says x is changing. X is moving up, moving down. The y is the one that's stuck, right? So this is behaving like f of x 1, right? Again, you can use any number you want. Okay, this will be telling with any number, with the exception of 0. 0 is deceptive. 4 times the x squared plus 6 times 1 cubed minus 8 times the x plus 5 times 1. Okay, so if I can take the derivative of what I see in the box, then that would be the exact same thing as what I see up here, because the y is acting like a 1. It's not moving up, it's not moving down from whatever that value is. All right, so derivative of 4x squared, 8x. Derivative of 6 times 1 times 1 times 1 is still 6, so 0. Minus the derivative of 8x, which is 8, plus the derivative of 5 times 1 is 0. And I'm done. 8x minus 8. Okay, so let's try that exact same thing when we take the derivative with respect to y. All right, let me just start all over. All right, so I have f of x, y equals 4x squared plus 6y cubed minus 8x plus 5y. All right, let me show you what I'm trying to find. I'd like to find df dy or f sub y. Okay, so what that tells me, I can look in both of these locations. I can say, oh yeah, the y is moving up and moving down. The y can change, but not the x. So this behaves like f of 1y. So let's see, 4 times 1 squared plus 6y cubed minus 8 times 1 plus 5 times y. Okay, let's have at it. Derivative of this one is exactly the same as the derivative of what I see above it. So the derivative of 4 times 1 times 1 is just 0, because that's 4, a constant. Plus the derivative of 6y cubed is 18y squared. Minus the derivative of 8 times 1 is 0. Plus the derivative of 5y is 0. So this is, oops, I'm sorry. This is wrong. 5. I got distracted. 5, right? Because that has a y in it. All right, so then my final answer is 18y squared plus 5. Okay, so having said that, we really want to think about if there's some type of a trick, something that might make it easier for us to remember how to take these partial derivatives, and there is. Okay, if the term has your changing variable, then you have to find a way to take the derivative. It's business as usual. Okay, it's an odd statement for some of the upcoming derivatives. If not, the derivative is 0. All right, so let me think about what that means. If the term has your changing variable, the derivative, it's business as usual. If not, the derivative is 0. Okay, so look at this one. Let's start here. We'll go backwards, work our way forwards. All right, so I wanted to take the derivative with respect to x. So look, that has an x in it, and this has an x in it. So look closely. Business as usual, 8x. Business as usual, negative 8. This does not have an x in it. Notice I just said, if not, derivative is 0. This has a y in it, not an x. Derivative is 0. This one, there's no x anywhere, so the derivative is 0. Let's see if that works on this other one. Look closely. So here, you should see that the y is changing. So I want to focus on this one and this one. So when I look down here, the derivative, oh yeah, business as usual. Here too, business as usual. Notice this does not have a y in it. Its derivative is 0. This one too does not have a y in it, so its derivative is 0. Right? So this is a fast way of taking these derivatives. Okay? So another example, working backwards. There you go. Here, I want to take the derivative with respect to y. Y was what I was interested in. Look, derivative as usual. This one, look, I should be circling this one, right? If I was looking at that. Business as usual. This one does not have a y in it. Its derivative is 0. Okay, so if I go over here, this is the first one I started. Notice I said pay attention to the x's. There it is. And look down here. Our conclusion, business as usual. This does not have an x in it. Derivative is 0. And that's it.